As I said, this is the webinar about the ontology semantic matching specific enabler, which is the one that we called FITMAN SeMa. So we are going to get through a presentation and through all this webinar showing why one should get this specific enabler, what it offers, the main functionalities of this enabler, and a brief description of the high-level architecture, and also a live demonstration. So, why to get such a specific enabler? Well, the main thing is that even today, interoperability between different organizations is still a crucial challenge. And when it comes to sharing documents or sharing data, knowledge, the problem is even worse. So you will seldomly find two organizations that share the same XML documents, have the same XSD schemas, and when it comes to people talking with each other that come from different organizations or even from different departments of the same organization, then the concepts that they refer to might have differences in semantics. So it's very difficult to have a homogenized view of data and knowledge. So the solution to that is something that will try to facilitate data sharing and data integration between these different entities, departments, or organizations, call it as you like. And we need something that will also support the matching of similar concepts so that people may talk to each other with different semantics, but understand the same things. So this is what our specific enabler tries to do when it comes to data and knowledge. So mostly XSD schemas and ontologies. So with this specific enabler, you get an infrastructure that's able to accelerate interoperability in the manufacturing supply chain. So it performs data schema matching, and you can change documents from one XSD to the other, which is quite valuable for enterprises that operate in a supply chain and that often talk to each other. So they don't have to change their schemas, they just have to find a way to do the mappings. And it also allows us to achieve a common understanding of knowledge, which is done through ontology matching. So you have an ontology A, and you have an ontology B coming from different departments or different organizations, and through matchings, people can talk to each other and understand the same meanings. So our specific enabler, what it does is that, first of all, it offers an automatic, semi-automatic XML schema matching and generates the according XSLT transformations. So you have two different XSDs, and through our specific enabler, you can generate the XSLT in a semi-automatic way that we are going to show in the demo. Actually, the system tries to guess the different matchings, but you can always intervene and define some correspondences or delete others that are not appropriate. The same is also done with ontologies. So you can match ontologies and you can generate the different RDF triplets, which will allow at a later stage querying these ontologies. One interesting thing and quite valuable is that this specific enabler interoperates with the generic enabler of FIWare that's called Semantic Application Support. And the main advantage is that using those enablers combined, you can have the feature what we call cross-ontology querying. So you can have on the FIWare generic enabler different ontologies, and through the RDF triplets that I mentioned in the previous bullet, you may do cross queries in those ontologies. And of course, as you generate the XSLT files, this corresponds to the first bullet, you can share it with your remote collaborators through a service, and people can pass it this over to machines in order to do then automatic matchings based on the default matching that you have specified. And the last but not least, GUI, graphical user interface, is offered. This is based on the COMA 3.0 toolkit, the community edition of this toolkit. And this is quite valuable for non-IT specialists. So everybody can import to XSDs, as you will see later in the live demo, and do the matchings. So, as I said before, what we wanted to do in this specific enabler was to create a so-called matching engine. So in order to go there, what we have done is that we have taken the FIWare Semantic Application Support generic enabler, which is a generic enabler that offers the ability to store and retrieve ontologies and to query ontologies. And we have combined also our knowledge of the COMA 3.0 Community Edition toolkit. So this toolkit is a toolkit that's offered by a university in Germany, and what it does is that it offers functionalities to match different XSD files, different ontologies. It has a quite high number of matching algorithms. Some of them are predefined. Some of them you can always write from the start. And it provides also some functionalities like putting some confidence coefficients for its mapping, and can very easily through its graphical user interface provide the mean for manual verification by users. So taking those tools together, what we have done is that we have created in our specific enabler an engine that creates and exports XSLT transformations, which is something that the COMA toolkit is unable to do at the moment. So the COMA toolkit only visualizes matchings, but does not export the result in order to be reusable by anyone. And we have also done the same for ontologies by creating and exporting the RDF triples, which are later stored in the generic enabler of FIWare to allow cross-ontology querying. And our specific enabler, has also a side repository that stores those transformations, which are also forwarded to the FIWare generic enabler. So, going very brief over our architecture, we have our specific enabler. The main part of it, which I said is the XSLT transformation tools extension, what you see here in the purple rectangle, which is built on top of the COMA toolkit. All this is based on Java, and this is actually the front end, what the user sees. Then we have a backend service, which is a remote repository that we have implemented based on MySQL database, where we store the different transformations. And there is also a service attached to this repository for sharing the different XSLT files with collaborators. So all this together is our FITMAN SeMa specific enabler, and this is connected with the generic enabler of FIWare for storing the ontologies and the triplets, and for retrieving ontology to do matchings. You're going to see this functionality in the live demo that will follow. So closing down this short presentation, the terms and conditions for using this enabler, which will be uploaded in the FITMAN catalog. At the moment we're running the last debugging steps, and we're ready to upload it. So we are going to offer it through the Affero GPL license 3.0, and we're going to offer it as an installable package. So you can download the package, install it on your own machine, and play with it. The COMA toolkit, which is included in this specific enabler, is also an AGPL package. which is offered, as I said previously, by the University of Leipzig. So I'm going to pass the microphone to Evmorfia, my colleague, in order to do the live demo for this specific enabler. Okay, Evmorfia, you can.
Yes, hello everyone. I'm Evmorfia Birili from NTUA, and I'm going to show you the live demo of the specific enabler. Okay, so here you can see the comma user interface. No, I don't know if you can see it. Sorry. Let me just share my screen. Sorry. Okay. So now here you can see the comma user interface. We have made some changes in order to support the new functionalities Sotirios described, but basically we have kept the same environment. Now, as you can see, the workspace and the repository are empty, so let's start by importing some XSD files in the repository from this option here. Okay, I will import these 4 XSD files, and you can see them here in the repository. I'm going to first show you a matching between 2 very simple schemas, just to see how the process works. So I will select this one as the source, and the target schema. Okay, now you can see they're imported in the workspace and they're visualized in a tree structure. Elements and attributes are presented in the same way. They're all tree nodes. Okay, COM offers a number of different matching strategies. We can find them under match execute workflow. These are the different strategies provided. Now I'm going to first choose this one. It is based on the node names. And this is why, as you can see, the node title has 2 matchings. Now the lines have different colors. The color is defined by the certainty factor of the matching. Now in this matcher, everything has a certainty factor of 1. So let's try a different one. Okay. Now, as you can see, the title has only 1 matching, the correct matching now. But the node name has no matching. It should be matched with the node title. Okay, so the user can manually alter any correspondences. Now I can create a correspondence between these 2, a matching. Right click and select create correspondence. Okay, the certainty factor is automatically set to 1 because this is a matching verified by the user. In case the matching is not correct, I can also choose to delete it by right clicking and select, for example, delete. Okay, this was a very simplified example. Now I'm going to show you a matching with data that were provided by FITMAN trial, a more realistic one. So I'm going back to the repository. I switch from here, and I will select this one as the source schema, and this one as the target. Okay. Again, I go to match, execute workflow, and select the default, let's say, matcher, the first matcher. Okay, now it's not easy for you to see that because of the size of the comma matchings are actually accurate, 100% correct matchings. Okay, but let's say that again I do not want this one. Again, I can delete anything I want. Now, this is what COM offers. There is no option, as Sotirios said, to export the matching in an XSLT file in order to use it for XML transformations. We have extended the program to offer that functionality. So here we have an XSLT menu with 2 options. I can create an XSLT file to be used for source to target and target to source transformations. I will start with left to right, source to target XSLT. I will name it test1 and click save. The XSLT file is generated and it is stored both locally in the file we just chose and also inside a remote database. We can keep this URL here so that we can later use it to retrieve the XSLT file or also provide access to third parties. Let me just show you. I can select and hit Ctrl+C to copy it. Okay, and use any browser to get the XSLT. Okay. So a new window automatically opens. View the file if you want. I'm going to close it and show you the other way around. I will also, create a right to left XSLT file, but I'm going to name test2. Again, we are provided with the URL. Okay, and this is pretty much the basic workflow for the XSLT matching and XSLT generation. Now I will move to ontology matching. First, I can clear my workspace from here. Okay. Now, as you can see, the repository still has the 4 XSD schemas that I imported. I did not save any of the match results, so this is why this space here is empty. Let's import some ontologies. Now, first, let me tell you that this part of the program, the ontology matching, is strongly connected to the FIWare Semantic Application Support Generic Enabler, which provides the means to effectively manage ontologies and their metadata. Currently, we do not have a connection to the generic enabler, so parts of the workflow I'm going to show you are not functional. Let's start again by importing some files. Repository schemas import file. Okay, I will import all of these into the repository. You can see them here. And again, as before, I will select one as the source and another as the target. I'll tell you that by importing an ontology file into the comma repository, it will also be uploaded and stored inside the generic enablers repository, which is not done at the moment. Okay, again, the same matchers can be used for ontology matching as well. So let's choose this one. Okay, now let me show you how you can actually store the match result this time. We can go here and change the name, match1, okay, and there is an option here to save current schema or match result to the database. Okay, so now as you can see, we also have the match result in the repository as well. And let me do one more time. Just to have 2 match results in the repository, and again save it. Now we have an option here under view to see the match result correspondences. These are the correspondences that are visualized in the other window. Now we use these correspondences to create RDF triplets which enable cross-ontology query execution by the use of the generic enabler. I am later going to show you exactly how this is done. I'm going to now close this. Now we have 3 options under the Semantic DB menu. They are not, none of them is really functional at the moment. I will show you an example of how they will be used when a connection with the GE is available. The first one, import ontology, allows us to import an ontology which is stored at the generic enablers repository inside the comma repository. This will be a list of the available ontologies. I can select and import the ontology into the local repository. Now, the second option allows us to create a workspace. This workspace will be stored at the remote repository, and inside we can store the ontologies and the match result RDF triplets I talked about earlier. Let's see how this works. I can give it a name, and then I can select which ontologies I want to import in the workspace and which match result triplets. Now we'll select 7 and 10. These are actually the 2 ontologies I used earlier to show you the matching. You can also see that here, every match result shows the corresponding ontologies. And if, for example, I thought the first matching was more accurate and I want to insert the corresponding RDF triplets, I can choose match 1 and then create. Okay. So this way the workspace will be stored inside the generic enablers repository. Now we can use the workspaces, we can query the workspaces by this third option here, query workspace. This will be a list of the available workspaces, and we will select the one we want. Okay. These are the available workspaces. These are these are the available ontologies that we stored in the workspace earlier. Okay, if I want to make a SPARQL query for the product ontology, I can write my query here, press this button, and the result will be shown here. When creating the workspace, I told you we had we could import also match result triplets. So if I did import the correspondences between product and catalog ontology, the result will also include results, will also be about the second ontology as well. Okay, this is it. I hope I explained it well. Oh. This is, I think, everything I had to show you. This is the basic workflow. Thank you all very much. Now, if it has something to add, or if anyone has questions, please feel free to ask.
Okay, thank you very much, Evmorfia, about the live demo. I just wanted to let you know before we go to the question and answer session that the connection with the generic enabler that Evmorfia shown, at the moment we chose not to have a virtual machine with the generic enabler running in terms of having more bandwidth for this webinar, because we are almost at the limit for this presentation. However, this is functional and will be released in the next couple of days together with the generic enabler that you have seen. And I will also upload now a slide with where you can find more information about this specific enabler. And the place for that is the FITMAN catalog. You can see it in the screen. And of course, you can contact me via email at any time in order to request some more information.